I am Jasper Kaliba. This is Group 61.
I'm Tyler Sperling. So we met up and did the lab together, and at the end we basically decided that it'd be easier to do a video so we could actually just show that we worked on it together pretty much. But starting off, like the first question, the way that we measured it was pretty straightforward. We used a string and the force sensor on the end to just get the total mass, the mass of just the cart, and then also the mass of each individual wheel.
What's the next question? And those pictures should be in the lab. And then to get the angle, we took the angle of this setup that we had. That's 2 books and a binder. So we took the
height and the base length.
Yeah, and then we took the inverse tangent of that to get the angle, and that was our decided on, just because these are the resources we had to make the angle.
Let's see, and then executing the experiment was fairly straightforward, and then we chose that the axis most relevant to the IOLab cart would be the y-axis, just because that was the central point of rotation that the object was rotating about.
And that was found by the y-axis is this one, so that's how we determined that. And then we did the experiment, and the force graph should be in the lab
as well.
And then to find the masses of each, we just took the force and we divided it by gravity.
0.8.
Yeah.
Okay.
So then to find the forces, to find the force acting upon it, we used mg sine theta, because that would be this force here. Oh, I can't really see it.
The force down the binder.
Yeah, that would be the force down the binder is mg sine theta. So that's what we used as the force to then calculate the torque. And then we didn't have a measuring tape because we just didn't bring it to this. But what we did is we measured it with a measuring tape on our phone. So that could be one little source of error, was that the measuring tape was in inches, and it's obviously a phone measuring tape, so it's not as good as an actual one. And we converted it from inches to meters. So we did that for the radius and all the measurements that we took of this. And another thing I'd like to note is that if you notice here, it's a little bit warped. It's not a complete circle, it's more of an ellipse. So
that could be another source of error.
Yeah, that could be another source of error, because when it rolls, it doesn't roll 100% correctly. Just because if you can kind of see it from a farther ways away, that these are actually stretching out the tape.
So for determining the experimental inertia, we treated the hoops how they were supposed to be calculated. We took the inner radius and the outer radius, multiplied that by half the mass. But then we treated the IOLab cart as a rod as opposed to an actual box.
Just because at this point in the lab, we didn't know the formula for the inertia of
prism.
Yeah, of a rectangular prism. So we said the most similar shape that it would be a rod, because it acts as an axle.
Yeah. And then
also we tried to calculate it through just the equation of angular momentum, where angular momentum equals inertia times angular velocity, but we couldn't determine the angular momentum from our graph, so we just calculated it this way.
Yeah. Then we started just using the one resource with the formula for the inertia of a rectangular prism. We calculated it out that way.
And then we just added all the inertias together
to receive our final inertia, which was slightly off, with 12.6% error compared to the calculated version. Yeah. And then the reason for these discrepancies would just be the fact that we treated the initial experiment inertia with the box as a rod, and then in the calculated one, we actually used the actual formula to determine its inertia.
Yeah, and then we just used the percent error equation to find the discrepancy, and we used the value with, what was it, the second value, the composite object, where we used the inertia of the rectangle as the actual one, and then we used the observed as the inertia of the rod, just to show the change in the two.
Yeah.
And then we calculated the discrepancy, which is, that discrepancy is only in the inertia of the rod or box or rectangle here, because the inertia of these, the tape was calculated the same way for each. And then if you see in the discussion questions for comparing results, we had the same, because Tyler, he had to send back his lab cart.
Because I bought the wrong plan for only 3 months instead of 4. So
So this is my lab cart, and we did it together for that reason. And yeah, our other members could not make it. So
yep.
all right.